This class is a part of an anemic domain model. Only in this video, and for your eyes only, I will show you how an anemic domain model leads to long argument lists, huge validation blocks, and a combinatorial explosion of methods. Take this video as the list of reasons against designing an anemic domain model. I will also share with you an offer from today's sponsor, Brilliant, that should all give you plenty of reasons to stay with me through this demo. Any anemic model manifests several obvious issues, all stemming from their primitive obsession. None of the values here is anything but an int, a string, or an enum. That comes with consequences. One immediate consequence is the lack of expressiveness. This should identify the language of the book. But it is just a string. It could be anything. That raises the request to sanitize the input. This class will throw if it cannot understand the value it has received. Let me remind you of my age-old opinion on this practice of throwing liberally. A class that throws is of little use to me. I want a class that works instead. I will keep this line for now, but you can rest assured that I will delete it with a smile before the end. This clump of data causes even greater worry. Data clumps are another immediate consequence of anemic modeling and primitive obsession. Several values are kept together to represent one thing. These 4 properties taken together represent 1 out of 7 possible publication states of a book. Could you even understand that by just reading the property definitions? I don't think so. And that proves my point that primitive obsession hurts the model's expressiveness. Another data clump goes along the same lines. These 3 values represent either an ordinal edition number, such as 1st, 2nd edition, and so on, or a seasonal edition such as Summer 2020 and similar. The existence of a choice makes all 3 properties nullable. It is such a pitiful data model in the end. I will now show you the numbers. They will demonstrate the immense impact of anemic domain modeling on the class's constructor. I was so diligent as to calculate that there are roughly 4,000 ways to get into the constructor. That observes all combinations of nulls, positive and negative integers, valid and invalid strings, and so on. Only 28 of those would result in an object. All other attempts will end in an exception. Therefore, we come to validation. There are 2 substantially different types of constructor validation. One is what you see here, removing nulls, negative values, empty strings, and similar unacceptable values. I should add guards for the edition number and the year number. Those are purely technical guards. They know nothing about the meaning of the model. Still, we must include these in every class. It reminds me of the story how inevitable death taxes and null checks are. Past this point, precisely 256 possible combinations are remaining. Of course, those same 28 combinations are valid still. But this is where we face a design issue. Any exception thrown above is because the caller made an obviously unacceptable call. Think of it. A negative ID or a negative year number, what do we do with that? The caller is guilty as charged, so we throw back at them. However, things change below this line. This is the case of a published book which is missing the publication date. That cannot be. While each value in isolation is valid, their combination is not, so we throw. But that is just the beginning. There are 3 other value combinations regarding the publication status that we consider impossible and consequently throw as well. Wait for a moment longer and you will see 5 other combinations within the edition data clump that are also impossible. Each of these failure modes carries its tailor-made error message. Given the complexity of the errors we raise, it also comes to mind that the argument exception might not be the best choice of an exception type. Anyway, that brings us to those 28 valid combinations at last. Look at this. It was 60 lines of code to get to assigning 10 values. Even those 10 values are inflated. It should be 5 at most. Still, the validation is inflated by 30 lines of code, not just a few. What if I told you that you can delete all these guard clauses and avoid throwing any exceptions only by following the common rules of object-oriented design? Maybe you're not convinced yet. Stay with me for 1 minute longer and I will show you how destructive anemic domain models are. This anemic model protects its integrity by throwing, in a way that makes me feel safe. But who's gonna handle those? We must step up the application stack into the book services class. The anemic domain model invariably comes together with the services layer. You may watch my previous video in which I explained how the services layer quickly becomes unmaintainable due to an anemic domain model. I will not repeat that story here. I will only show you the consequences of throwing all those exceptions from that anemic model's constructor. This is the line at which an exception may occur. Shall I handle it here? No, absolutely not. How do I handle the argument exception? I mean, it's the argument value that's not good. If I had a better value, I would have passed it already. You can never handle the argument exception or any other custom or built-in exception that indicates an invalid operation or value. What you do instead is to let it pop up. The exception becomes someone else's problem now. And who is that someone else? Well, shoot me, I don't know. It's some poor code which called my service. And now that code will handle a detailed exception generated by the domain model. There's one coding trick that can help mitigate the issue. However, as I apply it, you will realize that it quickly gets out of hand. This create book service builds a new instance of the anemic model, then populates it with data and saves it to the database. The root cause of the issues is that this service is public. By turning it private, I could control its arguments so that those guards over there in the constructor never throw. Doing so will be anything but easy though. Consider this exercise another nail in the anemic domain model's coffin. I will do it now so that you never do it yourself. There will be a lot of code from this point on. You can download the entire source code for this demo from my Patreon page. Let me remind you that every registered patron is helping hundreds of other fellow programmers watch all the videos on my channel for free. This is the direction of my thinking. I might expose a public method that creates a book that is not published specifically. That would mean no publication date or any part of it, and the book is not published. A single word, unpublished, has described the entire data clump. Isn't that wonderful? All my troubles seem gone. Would that it were so simple. There is also the question of the book's edition data clump. Whatever the choice of publication date is, an accompanying choice of the edition must be there too. That brings us to the story of a combinatorial explosion in anemic domain models. Each data clump brings one miniature explosion into the model. This one comes with 7 possible ways to set it. And this is how that happens. There are 2 ways to assign a nullable publication date, null or non-null. Each Boolean value comes with its 2 variants. That makes it a total of 16 combinations, but not all of them are valid. Only 7 combinations will pass by the guard clauses. Then comes the addition data clump. The addition number can be null, 0 or negative, or positive. Only the last one is a valid ordinal number. The seasonal addition data goes along the same lines. That makes a total of 12 combinations, but only 2 will pass the guards. How about combining these 2? That makes 14 independent ways to create one new book instance. Should there be 6 ways to set the other properties, the number will grow. Not the meaning of life you were looking for, I presume. We need to analyze all properties and data clumps before multiplying all valid outcomes to figure out how many independent ways there are to instantiate a class. That is 28 valid combinations in my code. This long multiplication chain is called a combinatorial explosion. Add just a few more properties and that number will go into hundreds, then into thousands. It might sound surprising to many, but the ideal number of ways to instantiate a domain class is 1. You can achieve that if you apply the rules of object-oriented domain modeling to a class like this. Think of it after you complete this video. We must return to the services class and now you will see that 7 times 2 explosion happening before your eyes. I am trying to construct a method which will cover 1 out of 14 combinations, the one where the book is unpublished and an ordinal number represents the edition. The only reason for this method to exist is to procure the correct combinations of values for the 2 data clumps. This public method will never throw one of the exceptions that cover combinations of values. The problem is that the method I have just written is only covering one possibility. Here is another one, creating a book whose printing is planned for a specific date in the future or in the past. And then the avalanche begins. There are a total of 3 ways to initialize a planned book. 3 more variants cover all the ways to specify a date for an already published book. That only got me halfway through, and look how much code there is already. These 7 service methods create books with an ordinal edition number. Another batch of 7 service methods would safely create a book with the seasonal edition. You see where this is going. Nobody writes code like this. That is the combinatorial explosion of methods. It is the direct consequence of the combinatorial explosion of states, which you have seen me explain a minute ago. I should probably delete all these methods and step back to an even less favorable design where a single all-encompassing public method does it all and, sometimes, fails in ways most miserable. I have shown you 2 decisions, a bad one and a worse one. Choose your poison. Both decisions are unwanted, and both are the consequences of having an anemic domain model in a domain that deserves a better, more expressive model. Redesigning this class would be a significant effort, which I will not do in this video. There are over 100 other videos on my channel that already explain domain modeling from all possible angles. I will invite you to watch them. And if you want to broaden your knowledge beyond just designing an object-oriented model, you can start doing that right now for free by visiting the sponsor of this video, Brilliant. Brilliant provides deep learning in specific areas of programming, engineering, and science. You will find thousands of interactive lessons in math, data analysis, programming, and AI. Whatever area you choose, Brilliant helps build your critical thinking skills through problem solving. Brilliant recently launched a ton of new data science content, all of which uses real-world data to train you. There is a full 30-day free of charge offer for you. Follow the link brilliant.org/Zoran Horvat, scan the QR code or just click the link in the description. That will also give you a 20% discount on an annual subscription after the trial period, so please make sure to use this link to unlock the benefits. And don't forget to subscribe to my channel and learn how to transform the anemic domain model into a proper domain model.